Hello. All right. So today I'm going to work on a predictive survey with Ekahau. Here I was given a floor plan of a house and some details, and someone told me that they have a house that's going to be looking something like this. These are the floor plans. There is a first floor, a second floor, a loft, but there's also a basement which is modeled off of this first floor, and I need to be able to get this information into uh, a wireless simulation. We like to use Ekahau, so I will use Ekahau to simulate RF throughout this site. So let me show you what that looks like. First thing I'm going to do is I will create a working folder for some images. So I will use my snipping tool and I will get a snip of the first floor. Save that in a new folder, and we'll call it House Simulation. And we'll call this floor 1. Okay. And we'll click over here and go into the second floor, jump back into our snipping tool, and we'll grab our second floor, save that, and floor 2. We'll go back to go over to the third floor, go snip that real quick. Call that loft. And as redundant as it might sound, we're going to take the first floor a second time for the basement. That's going to be just this area. We're going to save this as basement. So now that we have some images, we're going to work with our map. So this is Ekahau Pro, so we're going to add our map. And first we're going to do is find our house. So there's our house. And we'll start with our floor 1. So there's our floor 1, and it wants a scale. So if I go back over here to this image, and I look in here, the biggest number that I have that I can work with, great room is 18 by 13, dining room is 10 by 15, but this garage goes all the way to 19. Oh, if we go width, we could go, it looks like 24 feet 2 inches. That looks like that would be our width. So this is with the 4-foot extension. So we'll use 24 foot 2 inches, and we will measure against this wall right here. So 24 foot 2 inches. We'll go make sure that we have our preferences on feet. We do. So we'll just cancel on that. Maximize this. And we will go into ruler. Say here to here is 24 feet, and we'll just leave the inches. We'll hit enter. Okay, so roughly speaking, if we were to verify scale, if we zoomed in right here, it's about 3 foot, and that's what most doorways are. So that confirms that we have our scale looking pretty correct. Okay, so next thing we need to do is we need to add another floor. So let's add another map. Now let's add floor 2. Okay, we need to set scale on this too, and the biggest number that we can use is this 18 foot 2 inches, and we'll just kind of do the same we did last time. Let's see if I can center that. Go there. I'll go 18 feet on that. Okay. And let's add another map. Let's add our loft. And our biggest measurement is 13 feet, and it looks like it would be from here to here. So we'll go put that in. 13 feet. And last but not least, we're going to add a basement. So again, we don't know what any of these measurements are. But we will work with what we have. Just because I don't have any clear rectangles here, I'm going to work with the great room's 13 foot 4 inches, which actually I could use this right here, 18 foot 2. So I will measure this guy right here and come straight down. And we'll say 18 foot. Okay. Now I have all these different maps: basement, floor 1, floor 2, and loft. And thankfully that's actually pretty nice. So we'll just assemble this as a building. So we're going to create a new building. We're going to add all of these to the building. And loft is on the top, and then floor 2, floor 1, and floor 4. Okay. I don't know what our ceiling height is, but I'm just going to guess that we have an 8-foot ceiling in the loft. And let's say we have a 10-foot ceiling in floor 2 and a 10-foot ceiling in the main, and maybe another 8-foot ceiling in the basement. That sounds pretty common. And I don't know that we have necessarily, yeah, we've got office and thin floor, but we don't have necessarily house in here. So we'll just go with that. So before we do this, it wants us to align our floors. So what that means is we need to find common areas in this floor plan between all the levels. So one thing we can do pretty easily here is say, here's point 1. Ooh, we have to find commonalities in all the floors. So I don't know that we'll be able to find that in all of the floors, but we'll see what we can do. There's 1, 2, 3 on the basement. Let's go to floor 1, we'll do the same. So there's our 1, 2, 3. Okay. Yeah, that's not going to work, is it? Might have to move those floor alignment points. Let's start back at the basement. Let's go back to the basement. Okay, so maybe the foyer is a better place to add it. This is getting technical already. Let's see if we can move this alignment point. Maybe if we move this alignment point to right here, and then we'll go back to the first floor, move that floor alignment point. I'll go to floor 2. That might work for us. Let's try that out. 1, 2, 3. 3 floors are happy. Boy, so the loft is directly over bedroom 4. So it looks like we might actually have to play even tighter on these. So we'll go, oops, this guy, we're going to move him here, this guy here, this guy, oh my heavens, this guy right there. Okay, so that is second floor. Let's go into let's go into loft, and we'll go into floor alignment points. We'll go 1, 2, 3. We'll go back into floor 1. And we're just going to move our existing floor alignment points. Oh heavens, it doesn't align directly over, does it? 2. I don't know where it is. Oh, No, come on now. 3 goes over here somewhere. 1 goes over here somewhere. And then basement. 1 was in the bottom left. 2 was roughly around here somewhere. And 3, if I can get him, is over here somewhere. Maybe there's a window I can work with. Let me go back to floor 2. There's a window. Floor 1. Loft. So if I work there. All right, let me pause this for a minute and see if I can find it. All right, I seem to have found floor alignment points that make all the buildings happy. So I'm going to, so it is now happy and it is now a building. So I'm going to now go into my view and I'm going to hide my floor alignment points because they are all happy now. Next thing I'm going to do is I'm going to come up with coverage requirements. So coverage requirements, I like to use the Ruckus best practices, not just because we're using Ruckus hardware on this, but because it starts off with some pretty good assumptions. We're going to modify a couple things. Data rate, I'm going to say minimum should be about 100. Just copy and paste that. Should be pretty easy to hit. 100. In fact, we'll go 150 on the 5 gigahertz, which is going to also be pretty easy to do. We're going to make that our default. We're going to close that down. Okay, next, now that we have our, now that we know what we would determine best practices to be, let's go in and define where our areas are. So we're going to go in and set our area. And so this is our basement. Say, this is probably what the basement walls are. We're making an assumption. Okay. So we've got roughly a 1,300 square foot basement. Let's go floor 1. We'll do the same. Let's just assume for grins that my friends here have bought the expanded garage. So we'll do that. And let's go to floor 2. Here, make sure we grab all of this. I don't know if you can hear my squeaky mouse, but I can. All right, last but not least is our loft. Cool, 136 square foot. Kind of a fun little house. I like this design. One thing I'm going to double check in this area is, okay, good. It is grabbing my my coverage profile. So this best practices that we modified is what it's using here. We don't have any notes on that. So what we're going to do now is start off on floor 1. So now that we have our design, and I'm going to hide the area now that we're there. Next thing to do is actually going to be drawing in some walls. So let's draw in the walls real quick. And I'm just going to use a standard 3dB drywall for most of this drawing. Let's start off by drawing over all of the outside of this facility. We'll just assume, you know what? Make this a 4dB wall just in case. Grab a 4dB. That way we over predict the interference. Oops, my heavens. Let's try that again. All right, now these are interior, so we can easily go with a 3D view wall on this. Okay, and let's move up another level. So we'll go to second floor, and we'll start with our outside, and we'll just say that it's nice and thick on the outside. It's got insulation, so 4dB might be appropriate. Not sure what they're insulating with these days. Maybe they're trying to protect everybody from the 5G coronavirus, because I've read about that on the internet, and apparently you don't want that. I'm not sure how you get it, but maybe Verizon knows. All right, making progress. Redo that last one. I think I can do better than that. What did we forget? Oh, okay, we got some walls. Let's go into our loft. And did we do our basement walls yet? So we don't really know what our walls are going to be like on the basement, but it's likely that it's going to be concrete on the outside. Again, unless if builders are using something new and exciting that I don't know about, which wouldn't be the first time. But we'll make sure we try to survey as appropriately as possible. So we'll go back to our 3dB wall from the inside, and we'll just draw similar walls to what we saw on the main level. It's unlikely, but it's possible that this is what the walls will look like. Okay, so we've got some walls now. We know what those are going like. Okay, so next thing we want to do is we want to hide those walls. Let's just make sure that we do have walls, in fact, on every level. So basement, floor 1, floor 2, and loft. Perfect. So if I go to view and I'm going to turn off these walls, where are they? At the bottom. Cool. So we'll start on floor 1. Now we need to simulate an access point, and we know that there is supposed to be an R510. Oops. If I spelled correctly, R510. Okay, so in theory, right here, there is a Ruckus R510 access point, and it's simulating that it's at 7.9 feet. But that's actually not where I would put it. I would put it up at the ceiling, so it'd be sitting about 9.9. Oops, 9.9 feet. And it says, let's say that we're rocking 12 dBm. Okay, so not bad. Not bad. And you can tell that by the shape that this is in fact reacting to walls. So if we go and we look at the basement, you'd see some level of signal, but maybe that's not enough. Now, I don't actually like to keep the R510 on this level, considering there's a great room over here that's likely going to have a TV and some other devices. So what I'm going to do is I'm going to delete this access point, and I'm going to drop in a different one, because the R510 is fantastic, but I like the H510. I don't know if you're familiar with it, but I'll show you the difference real quick. So an H510 has a 4-port switch built into it. So it will, on the back end, it has, it plugs into a socket. You can get a short little network cable and it'll mount to the wall. And then you have 4 gigabit ports there. The R510 is a ceiling non-access point, and the H510 can sit behind the wall, behind like an entertainment center. So I think that's going to be a pretty good fit for this main level. So we'll take an H510 and we'll put it right here. And you might notice that this is not fantastic coverage. So we're going to expand this real quick, and we will edit this guy, edit. H10 main. Okay. And we are actually putting him at a height of, let's say, 4 feet. And on the 2.4, we'll blast it to, let's double check what the spec says for this device. Specifications. Let's go to the data sheet and have a look. 12 watts, and it likes to transmit somewhere around 16 dBm. So that 16 would be top. So let's say that we're rocking about 12 dBm on both. Okay, I think that's realistic. So if we'll rock that. Okay, let's go up to the second floor and let's reuse that R510 that exists. Now, I know that master bedroom is one of the more important areas. Master bath is also going to be kind of critical. So why don't we just drop an R510 right up here on that main floor? And that's going to give the master pretty good coverage. It's going to give adequate coverage to all the other areas. Now, if we don't know what else exists in here, maybe bedroom 3 is an office, and let's just assume that it might be. Out of curiosity, before we add another one, I want to see what goes on in the loft. And the loft is not exactly happy. Let's go back to floor 2, and we're going to give a name to this AP. We'll call it okay, and that is actually at 9.9 feet. And we are at pretty certain that this one lasts a little bit louder than the other. So let's go to documentations and downloads, and we'll go to the data sheet and make sure that we have the right broadcast strength on this. And where do I find that? Eeny, meeny, miny. There's the wattage. Where's the transmit? Okay, about 19. So we can go a little bit louder. And let's say that we're at 16. 16. Okay. And our coverage is pretty good on this floor. And if we look on the loft, we also have coverage up there. I don't know. Oh, and we definitely don't need neg 65. We're only looking for neg 70 everywhere. And it looks like that would work pretty well. Let's also make sure that our signal strength prediction is current 4 plus 1. So we're able to see, if I was hanging out up here in the loft watching my YouTube videos, neg 63 from floor 2 is access point on either channel 36 or channel 1. I think that's fine. We don't need another one up in the loft. Let's go back down to the basement and see what we see. So we can definitely tell that the great room has something. And I don't know where the entertainment area would be here. There's water here, so there might actually be a bathroom. There might be an office in here. So let's assume that there is. And we're going to go with an access point, and let's say maybe another H510, and we're going to drop it right here. So this H510 is going to be down here. And for the basement, we're going to edit this, and we're going to call it basement H10. And this is wall mount. And we are at the height of, let's say, 4 feet again. And this one we're going to blast. So I'm going to say we're at 16, and we are at 16. Okay, so if we hide the access points, we find some areas that do not necessarily have great coverage. This is not met neg 70. If we look back up on floor 1, we don't have neg 70 here either. Now, most people would argue that Wi-Fi in your garage is non-critical. And for floor 2, it's actually looking quite good. So if we were in that front bedroom, we're able to get the Netflix, neg 59, neg 60, all that's fine. And if I expand all of these APs on the left, 12 and 16 dBm is quite fine. So we have one in the basement, one on the main, one on the second floor. But it looks like if we were to add another AP here, we would probably be doing a little bit better. So let's add an R510 back where it normally existed and see if that makes a difference for us. So let's go back, and we will grab an R510. And if we put one back in the foyer where it would have existed, and we're going to call this, let's give it a name. Name R10. And we're going to put it back up on the ceiling. A ceiling mount, that's fine. And we will go to, what were we on the second floor? 12 and 12. Okay. Now, if someone was off in the garage trying to do some work, they will be able to hear signal on the basement and the main floor. Let's go back down to the basement and make sure the signal is propagating. And it appears that it is. So again, we don't know what's going on if maybe we needed to move an AP, but having these APs. Oh, and with here, we're actually able to aim the AP. I don't know if I did that properly on the main level, so let's make sure we did that. Oh, that wasn't helpful. Let's go and put that on that wall facing out, and now the signal propagation is a little bit more accurate. You'll notice that these wall APs are directional mount, so RF energy is going out the correct direction. So floor 1 definitely looks good. Coverage is nice. Basement coverage is actually pretty good too. If this is a critical area, we might talk about adding another AP, but everything appears to be right there. So let's look at all of these APs again one more time, make sure that we have the correct heights for all of our APs. And last but not least, let's double check our loft. So if I'm up at the loft, what am I able to do? Neg 64, that's fantastic. So how many APs are we looking at now? Well, we've got a total of 4. So we've got an H510 in the basement. We've got an R510 and an H510 on the main level. And then we have an R510 up on the second floor, kind of in that main area. And that appears to be giving good enough signal everywhere that if you're in the master or if you had an office in one of these 3 rooms, you'd be just fine. And the nice thing is that not only do you have the AP on that main level, but you're also able to see the APs on other levels. So, and we're viewing this as mobile. So if we were to predict as a stronger device like a laptop, you might even have better signal strength. And now we're able to see floor 1 and floor 2 APs. If I jump down to the basement, I no longer have a problem so long as I'm not on a mobile device. I'm able to see ones on the main and even, floor 1 and basement. Another thing we can do real quick is we can simulate a 40 megahertz, 5 gigahertz channel. We're not going to disable any 2.4 radios for now and see what it looks like. So that is nice. And if we go from signal strength to, I want to look at channel interference and see what things look like. So we're fine here. Let's look at floor 1. So there's a little bit of channel interference here because we've got channel 6 on the main, floor 2 and the basement. Okay, and they can hear each other. That's fine. And if we go all the way up to the loft, it looks like we're fine. We don't have any interference to worry about. Okay, yeah, so this looks like a pretty good device. And this is view as measured. And if we go as view as a mobile device, again, there we are. So this is how to do a quick and dirty simulation. This is what it looks like for signal prediction using a few different APs at spelled out heights in someone's house. And from this, we're able to come into reporting and do a one-click report. And we'll just call this home simulation. And I'll just leave everything connected and I will undo things later. And I'm going to leave this as letter and DOCX, and we'll call this home simulation. Let's see, what do I care about? I care about signal strength. Secondary is nice. Tertiary, I don't care about. Channel interference, we've already identified, don't care about that. We'll worry about data rate, not throughput. Not worrying about connectivity or spectrum. We'll talk roughly about, no, we don't worry about that. We'll spell out the requirements. We're not worrying about capacity or Bluetooth. We will spell out that, but not that, or that, or that, or that, or that. And we will generate our report. And let me pause this for a minute while we see what this looks like. Okay, so I've put together a quick report, and this is what it looks like. So this is the predictive simulation against the Evans floor plan. And it starts off by each level. So in the basement, we've got one AP, we've got the coverage requirements and everything that we spelled out initially. We've got the signal prediction for 2.4 on the primary and 5 gigahertz secondary signal strength as well. So what are we hearing from other APs? Signal to noise ratio. SNR looks fine. The data rate also looks pretty good. Most of it's over 400 megabit. In the basement, again, we have that one AP. We even have its configuration for channel 6 and channel 36. On the main level, we have the two APs, we have the direction, we have that same configuration as before. We have prediction for 2.4 and 5 gigahertz signal. We have our secondary signal strength on the main level as well, SNRs as well, data rates as well, and again, placement of those APs, configuration of those APs. And going up to the second level, we have the single AP. Here are our coverage requirements. Here's our prediction for 2.4 signal, prediction for 5 gigahertz signal, our secondary signal strength, going SNR, looking for data rate on 2.4 and 5. Again, location of that AP, configuration of that AP. Going into the loft, we have coverage requirements, but we have, and here's our signal, but we actually have no AP. So secondary signal strength is not there. SNR is not awesome. Then again, it's a loft, so we're not worried too much about that. And again, there's no AP up in the loft, and that is it. So this is how I use Ekahau to design and predict signal. Hopefully that was helpful. Thank you.